This is question number 7 in our Unit 5 Assessment Study Guide. A company is designing boxes in the shape of rectangular prisms. The company makes a small box that contains 1.2 ounces. Note, ounces are a measure of volume. So 7A asks us to explain or show our reasoning for how many ounces will the extra large box contain. If they tell us that the extra large box will be a dilation of the small box using a scale factor of 4. So first you need to remember that the new volume is equal to the old volume, or the original volume, times our scale factor, K, to the third power. So I highlight this because it's really important and it's not on our reference table. So if you remember, as a side note, when we were talking about new area, we took our old area and we multiplied it by the scale factor squared. Do you remember that? So now it's like a similar concept, except instead of squaring our scale factor, we need to cube our scale factor, so raising it to the third power. And as another recall, we also did new perimeter. And in the past, we said new perimeter is simply equal to the old perimeter times our scale factor. We don't have to square it, we don't have to cube it for the perimeter. It is just times the scale factor. Alrighty, so really we're focused on the one that I highlighted for volume. New volume equals old volume times scale factor raised to the third power. So they gave us that the small box contains 1.2 ounces. All right, so we're going to use this new formula that we have. So the new volume is going to be equal to the old volume, which is 1.2 ounces. And they gave us a note saying that ounces is a measure of volume. And we're going to do times scale factor cubed. So our scale factor they gave us as 4. So we're going to take this 4 and we're going to cube it. Remember, it's really important that you're cubing your scale factor in order to get the new volume. So we're going to multiply the old volume times scale factor raised to the third power. And our new volume then should be equal to 1.2 times 4 cubed, which is equal to 76.8 ounces. That's going to be your final answer. And we're going to move on to part B. Another box will be a dilation of the small 1.2 ounce box. It must contain 18.75 ounces. What scale factor does the company need to use for this box? Explain or show your reasoning. So this is kind of working backwards to then find the scale factor. Unlike part A, the scale factor wasn't given to you, but now you have the old volume, I'll highlight that as blue, which is 1.2 ounce. And then it also has a new volume, and highlight that in red, which is 18.75 ounces. So we're still going to use this formula where we have, I'll write it out again, new volume equals old volume times scale factor cubed. And we're just going to plug it into this formula. So I have 18.75 ounces equals, the old volume was 1.2 ounces. I'm going to multiply that by the scale factor cubed. And so I'm going to divide both sides by 1.2 ounce to get rid of the 1.2 on the left side so that I can get K raised to the third power, K cubed by itself. And I have 18.75 divided by 1.2. To get K by itself, I need to actually do inverse operation, which is going to take the cube root of both sides. So I'm going to take the cube root of both sides. So as demonstration, if we have, like, for example, K squared, right? And I gave you a number. Let's use the same numbers. If it was squared instead, you would take the square root of both sides, right? And actually, I'm not sure if you knew this already, but when you take a square root of both sides, there's actually an invisible 2 here. It just doesn't show. So it's a similar concept, but this time, since it was raised to the third power, we're going to take the cube root of both sides so that these 3's cancel out, and I'm just left with K is equal to the cube root of 18.75 over 1.2. And when I plug that into the calculator, I can go to math. Then I can either go to number 4, which will give me cube root of something. Or I can go to 5, which will give you some root that you can then change here. And you will get the same answer. So your answer should be 2.5. K is equal to 2.5. That is our scale factor, which is the answer to the second part. For part C, it says a small box's volume of 1.2 ounces is about 2 cubic inches. The large box will be a dilation of the small box using a scale factor of 3. So just like the first example, in part 3, they gave us the scale factor. Find a possible set of dimensions for the large box and round your answers to the nearest tenth if necessary. So they just want us to find one possible set of dimensions for the large box. So your answer will vary for part C, but I can lead you through one of my answers, one possible answers. And so first, I need to figure out what the new volume should be. So I'm going to use the same formula. New volume should be equal to the old volume. and they did a conversion. So they said 1.2 ounces is about 2 cubic inches. So actually we no longer need to look at the 1.2 ounces. We can just use 2 cubic inches. So the 2 cubic inches times my scale factor cubed. My scale factor was given to me as 3. So I'm going to take this 3 and I'm going to cube it. That is going to be my new volume. And when I plug this into the calculator, I get that the new volume should be actually something that is 54 cubic inches. So I can say, okay, new volume is equal to 54 cubic inches. Now it says find a possible set of dimensions, and I know that this is a box, so I know I can just do length times width times height. If you go back to the top of this question, it says a company designing boxes in the shape of rectangular prisms. So you can think about some dimensions for a rectangular prism. And one possible solution would be maybe you can set the length to 6. The width is maybe 3. And then the height could be 3, because then I know that 6 times 3 is 18, and 18 times 3 is 54. So it's going to be 54 cubic inches. And so these were the measurements for one possible set of dimensions for the large box. What is highlighted here, I'm going to write again on the bottom. And this is going to be my answer for part C.